Hello everyone. Let's solve this problem on AP Physics 1 Kinematics. It says at time t equals 0, a car starts from rest and begins to drive along a straight horizontal track. The graph shown represents the position of the car as a function of time squared. Which of the following statements correctly describes the motion of the car? So the options are given to you, which is the car moves with constant speed, momentarily stops, and then moves again with the same speed. The car is slowing down at a constant rate, then speeds up but at a slower rate. The car moves with constant speed. The car speeds up at a constant rate. Now let's see which option is correct. So we have the position plotted along the y-axis and we have the time squared plotted along the x-axis. Now, if we denote the position as x, so we have x plotted along the y-axis and we have t squared plotted along x-axis. Now let's look at one of the kinematics equations which says that the position x after a certain time t is given by the initial position of the object, which is x naught, plus 1/2 at squared. All right, so in this case, it is saying at time t equals 0, a car is starting from rest. So if we compare this equation with this situation which is given to us, for us, x naught is equal to 0 at the beginning because it's starting from rest. All right. So we can take x naught equals 0 for this specific problem, and then this equation becomes x equals 1/2 at squared. Now, if you compare this equation with that of a straight line, the equation of a straight line is usually given by y equals mx. So y is the y-axis. So we have plotted x along the y-axis, and the x represents the horizontal axis. So we have plotted t squared along the x-axis. So now we are left with the slope. So the slope according to these two equations should be equal to 1/2 of the acceleration. So therefore, for this particular graph, we can say that the slope of the graph is given by half of the acceleration of the object. And since it's a constant slope, you can see that the slope is remaining constant all through. So that indicates that the acceleration is constant. So the object is moving with a speed which is constantly increasing. And that suggests that option D is the correct choice, which says that the car speeds up at a constant rate. Now, some of you may ask a question like, why is the slope negative? And what does it truly indicate in terms of visualizing the scenario? So if you consider a reference frame, say we have something as a reference frame, it could be anything, and you know the definition of reference frame, a point about which we can locate the position of any other object. So if we have the reference point or the reference frame indicated with an X and say this is where the object is at the beginning, so it is going towards the reference point in the negative direction, but it is speeding up. It's not maintaining a constant speed, but it speeds up at a constant rate. And this is what this graph is showing. I hope it is clear to you now. And thank you for listening, and please subscribe to my channel. Thank you for now. Bye-bye.